Hey learners, hope you all are doing well. Welcome back to my channel. Continuing with our DSA series, that is Data Structures and Algorithm series. In the last session, we discussed about what is data object, then data structure, abstract data type. Today, we'll discuss what are different types of data structures. So without wasting time, let's start with today's session. But before that, if you haven't subscribed to the channel, please do that by clicking on the bell icon. Today we will be discussing different classification of data structures. Now these data structures are classified on different criteria, like are these data structures inbuilt provided by the programming language itself, or is the programmer designing it? They are called as user defined by using the existing data structures. Getting? So we call them as primitive and non-primitive. We will be discussing this in the subsequent slides, in the coming slides, don't worry. But this classification is based on whether the data structures are inbuilt provided by the language or are they custom created, that is user defined. Okay, that is the programmer designing it by using the data structures which are given by the language itself, or are they coming along with the language itself? So they are primitive and non-primitive. Second classification is based on the organization. Means all the elements in your data structure. In the last session we have discussed about what is data structure. So it is domain, function and axiom. And what is domain? They are data objects. Data objects are set of data elements. So how those data elements are organized? Are they organized in a sequential manner? Meaning, are they associated with each other in a sequence or in a linear way? One is one element associated with next with next. Getting? So there is a 1:1 association. And if there is no particular order of association between the element, accordingly we call them as linear and non-linear data structure. Getting? Like if we are standing in the queue, right? So it is in a linear manner. Okay, but when we show the hierarchy of our family, who is the parent, then their children, they all are siblings, children's children. So there we don't have a sequential order, isn't it? So linear, non-linear. Then depending on the allocation of memory also, data structures are organized. Means how the memory is allocated. Means whether the size of your data structure is to be announced at the time of compilation. And then runtime we cannot grow or shrink it. Okay. Or we are allowed to allocate and deallocate the memory as per our need during the execution. During execution, you can allocate the memory as you need it, and if you don't need it, give it back to the system so that it will get garbage collected and it can be reutilized. And how much memory is to be allocated, everything is in the programmer will. According to that also, we have data structures like static and dynamic data structures. And last is, depending on are the values preserved or lost. Getting? Based on that, we have persistent and ephemeral. Ephemeral means we can recall the past value, and we cannot. And when we can, then we call it as persistent. Getting? So persistent and ephemeral. All this in detail quickly we will see in the coming slides. Then we have to implement this in the coming sessions. We will implement it using C. If possible, I'll try to show you the implementation in C++, even in Java, which will help you in problem solving. Different company aptitudes, you can clear it with the help of it. First data structure which we are going to discuss, that is primitive and non-primitive. Already I have told you the classification primitive non-primitive is based on whether it comes along with the language itself, means is the language designer only has decided it, or using it programmer has created it, that is custom created, user defined we call them as. The primitive non-primitive you can call built-in, inbuilt, or user defined. Even we call it as derived because it is derived from the existing one. Okay, you can call it as scalar and vector. You can call it as elementary group type, elementary type. Okay, so accordingly we do the classification. So when the data structures are coming inbuilt, that is the language designer only has decided it, then we call them as primitive. So primitive data structures are built-in data types provided by any language. As we are discussing all these data structures and algorithm using C, I'll give the list of primitive data types provided by C. Okay, and non-primitive means those data structures which are user created by using this primitive. They are either called as user defined or derived data type. The non-primitive data structures are derived data structures derived in terms of primitive. So we'll take this primitive and create our own. Clear? Also called elementary type or scalar type. Primitives are also called as elementary type, that is the basic type, inbuilt type. Scalar, why? Because they can hold only single value. That is a reason we call it as scalar. They are called as group type because they are derived from the existing one. The group type, why? Because here you can store multiple value. Getting? And group of values is also called as an array, or we can even call it as vector. Then some primitive data structures provided by C, example like int is for whole number. It will have its decided range and size. That too depends on the architecture. Like if you are in 32-bit architecture, int takes 4 bytes and it can hold positive, negative, both numbers. So accordingly, they have their range like minus 2 raised to 31 to 2 raised to 31 minus 1, which is approximately plus minus 2 billion it comes out. Character is actually an integer only, but a 1 byte integer in which we will be storing the ASCII code of different characters, because ultimately in computers memory everything is in the form of zeros and 1. So your graphical letters A and B and C which we see on the screen, in computers still they are represented as 0-1 pattern. So every character will have its code, and that code we store it in character data type. Float, numerical value, but they have a decimal part also, recurring values which are not fixed value. So float, also called as real in some languages. Short and long are the qualifiers which we use along with int. Like if you apply short to int, it will take the half the size of integer. Long, if we apply with int, it will take the double size of integer. Whatever is the size of int, double of it. Getting? Then these two actually qualifiers which we use along with int and long. We have another qualifier also called signed and unsigned, which C provides. Double is like float only, numerical values with decimal, but the decimal part is having higher precision, around 15-digit precision. Here we have 6-digit precision. Then non-primitive in C. The famous non-primitive data structures in C are arrays. Array is also called as a group type or vector. It is a collection of objects, or collection of elements, data elements, but they all are of same type and they are stored in memory in a contiguous form. Everyone is identified by an index and they all share some common name. A common name, but every element is recognized by a number. They all are in a continuous memory and their type is same. So you can say array is a non-primitive type, but it is a homogeneous collection of elements. Homogeneous why? Because all are having same type. One more which C has provided, that is structure, struct. It is also like array. It is a group of elements, but they are not necessarily of the same type, but they are logically related. They have some logical connection with each other. Like you are storing information of a student. So we have a roll number, then name, then percentage. Their types are different. Roll number is an integer, name is a character array, percentage is a float. They're different, but they all are represented as one group. So they all come under non-primitive category. Array is a collection of homogeneous type, elements stored in continuous memory. All the elements are of same type, but they are kept in memory in a continuous form. And everyone is of the same type. They share a common name. They are kept in memory at a fixed distance apart. Structure, which is provided by C, is very much like array. It is also called as user-defined data type. But only the basic difference is here it is collection of dissimilar type. But all those are related to each other. They have some logical connection with each other. But according to storage mechanism, they are also stored in a continuous memory. They are also group type, or you can call it as a non-primitive type or derived type. So I hope this classification is clear. In this classification of data structure, only the basic thing is, are they provided by the language, or is the programmer using those inbuilt languages, build data types provided by the language and creating his own. So if he is creating of his own, it is non-primitive, and those which are given by the language itself, they are primitive. Coming quickly to the second classification, that is linear and non-linear. Now this classification is not based on who is providing it, whether the language or whether the programmer is making. This is based on the organization in the memory, how they are kept in memory. The first is linear and second is non-linear. Linear, the name itself suggests all the elements, all the data elements are kept, or they are organized in a sequential way, one after another. Possible they are kept in scattered memory, but they're connected to each other in a sequential way. Means one element is having relation to the next one. Next is having relation to the next. 1:1 relation is there. As I said, we are standing in the queue. So we are in an order. We are in a linear way. First, then the person standing behind, then standing behind. Isn't it clear? That you can consider, or you go to a toll booth, petrol pump, everywhere you can see one order is maintained, isn't it? So that is a linear organization. Non-linear means the elements don't have any particular association. The order is not maintained. They are associated with each other in any manner. Like I'm representing a family tree. One is associated with 3. they can be further associated with some other element. Okay, or you can consider a graph where different vertices are there and they are connected with other vertices by edges, but which vertex is connected with any other vertex, that depends on the organization of that graph, isn't it? So linear and non-linear. Every element is related to its previous and next element, meaning whatever elements are there in your memory, everyone is associated with the next one. Next is associated with its next. Here, every element is attached with many. Means you can say here it is a 1:1 association, whereas here it is a 1:many association. Getting? Data is arranged in linear sequence. Means they maintain an order, they maintain a chronology, they maintain a sequence. You understand, the sequence? As I said, we are standing in the queue, we have maintained one sequence. Getting right? When you make a garland for God, so all the flowers are put into one thread. So all the flowers are in one sequence. You understanding? Okay. Data is not arranged in sequence. Here no sequence is maintained. Data items can be traversed in a single run. Single run means you got, if you want to traverse the elements, just you have to go to the first element. From there you can go to the next, next, next. The sequence is maintained. Here the traversing doesn't have any particular order. Getting? Like if it is a tree, so I can traverse it in a level by level manner also, or first I'll go to the parent, then the first child, now there are no child, I'll come back to the parent, then go to the next child. So there is no particular order of visiting. Getting? So data can be traversed, cannot be traversed in a single run. If the programmer wants to implement linear data structure, it's quite easy to implement. Non-linear data structure, little difficult. Still, you can do it. Already, I have mentioned it in my many sessions, nothing is impossible. Implementation is not impossible, difficult. At a first stage to understand it is difficult. As you go on becoming pro or you go on becoming expert in it, you'll start understanding it. Few examples of linear I have given. A best example is an array. Array is a large collection of homogeneous elements. Homogeneous means all the elements are of same type, meaning every element will take same amount of memory. Getting? If you are not aware about array, you can go to my C lecture series. In that, attend arrays sessions. You will be very well clear with it again. Okay, so you can see all the elements are of same type. They all are in a continuous memory. They all share a common name, and every element is recognized by a number called as an index. So can you see they have a sequence? They all are kept in a linear manner. Getting? You can take a stack. Stack is a list of elements. Only the thing is, the way in which that memory is manipulated is different. Here you can add or remove only from one end. From here only you can add the elements or remove the element. That is push and pop. Getting? That is called top. But still the order is maintained. Then we have queue. Here you can add from the tail, that is rare, and you can remove from the front. Real life queue. First come, first serve. Who comes late, add in the tail. Who is first will get the first service. Still the order is maintained, linear there. Linked list you can consider. This is a collection of nodes. Maybe they are scattered in the memory, but they are bound to each other with a chain. A link is there. This element is having address of the next. This element is having address of the next. therefore still they are in a linear manner. Getting? Then some examples of non-linear. The best example is tree. We will be discussing about this tree, then the properties of tree, different types of tree, how to implement a binary search tree, how to do traversal on that binary search tree. And these all are very helpful in problem solving, especially if you are solving lit code platform. Lit code is one platform, and on that platform, if you are solving the questions, it will be really helpful for you. Can you see here? It is a parent-child relation. There is one element called parent. These are the children. The children will have their children. They will again have their children. These are siblings. Getting? You can say these are the ancestors of this element, or they are the successors of this element. In graph, there is no order maintained. These all are vertices, and these are the edges. There is no particular order only of connection. Getting? Quickly moving on, I hope you all are clear with linear and non-linear data structure. Quickly moving on to the third data structure, that is static and dynamic data structure. Okay, now these data structures are classified on the basis of when the memory is allocated, where the memory is allocated, and how that memory gets destroyed. In simple terms, when they are born, when they die, and where they enjoy their life, in a simple terminology. Getting? कि ये एलिमेंट्स कब बनते हैं, कब डिस्ट्रॉय होते हैं, एंड कहाँ उनकी स्पेस एलोकेट होती है, उसके बेसिस पे इनको क्लासिफाई किया गया है. Getting? तो स्टैटिक and dynamic data structure. In case of static, what you have to remember is how much amount of memory is to be allocated, that you have to announce at the time of compilation only. Getting? And later you cannot shrink it or grow it. उसको बढ़ा नहीं सकते, कम नहीं कर सकते. Getting? तो कितना मेमोरी एलोकेट करना है, यह हमें कंपाइलेशन के समय अनाउंस करना पड़ेगा. मेमोरी रन टाइम ही होगा, मेमोरी ये रन टाइम ही एलोकेट होती है, बट कितना मेमोरी एलोकेट करना है, हाउ मच मेमोरी इज टू बी एलोकेटेड, दैट यू हैव टू डिसाइड एट द टाइम ऑफ कंपाइलेशन. तो उसको एंटिसिपेट करना पड़ता है. मीन्स अप्रॉक्सीमेटली लाइक इफ आई वांट टू एलोकेट 50 एलिमेंट्स, तो मुझे उसका डबल एंटिसिपेशन करना पड़ेगा. पहले ही मुझे 100 के लिए प्रोविजन करके रखना पड़ेगा. गेटिंग? बट बाद में आप उसको श्रिंक नहीं कर सकते, जरूरत नहीं इसलिए दे दिया. गेटिंग? ग्रो नहीं कर सकते, और की जरूरत है तो एक्सटेंड कर दिया. दैट इज नॉट पॉसिबल. एंड डायनामिक मीन्स हाउ मच मेमोरी यू आर गोइंग टू एलोकेट. गेटिंग? इज कंप्लीटली अंडर प्रोग्रामर्स कंट्रोल. बट ये करने के लिए हमें स्पेशल लाइब्रेरी का हेल्प लेना पड़ता है. एंड कुछ लैंग्वेजेस ने तो दिया है फैसिलिटी, लाइक C++ ने कुछ ऑपरेटर्स दिए लाइक न्यू एंड डिलीट. बट C में आपको मेलॉक, फ्री, ऐसे लाइब्रेरी फंक्शंस यूज करना, क्योंकि वो इनबिल्ड फैसिलिटी नहीं है. गेटिंग? दैट विल डिस्कस मोर व्हेन विल कम टू डायनामिक एलोकेशन कॉन्सेप्ट. ओके, तो स्टैटिक एंड डायनामिक. बेसिक डिफरेंस क्या है ये क्लियर है कि इन केस ऑफ स्टैटिक द अमाउंट ऑफ मेमोरी विच यू वांट टू एलोकेट, गेटिंग, दैट यू हैव टू डिसाइड एट द टाइम ऑफ कंपाइलेशन ओनली. रन टाइम यू कैन नॉट ग्रो इट और श्रिंक इट. ओके, वेयरएज उसका ऑपोजिट ये है, how much amount of memory you want to allocate, you can decide at runtime, and when you don't want it, you can give it back to the system. उसको हम garbage collection कहते हैं. Back to system दे दिया तो system उसको reutilize कर सकता है. अभी कहोगे system means what? Your operating system. because memory allocation and deallocation is the job of operating system. ऑपरेटिंग सिस्टम की वो एक बेसिक रिस्पॉन्सिबिलिटी है. स्टैटिक के कुछ ड्रॉबैक्स है कि रन टाइम कुछ एलिमेंट्स हमें इंसर्ट करना है तो बहुत टाइम कंज्यूमिंग है, क्योंकि ये पूरा अलोकेशन पहले ही कर दिया था. तो एलिमेंट्स कुछ अंदर इसमें इंसर्ट करना है. इफ यू वांट टू इंसर्ट द एलिमेंट इज वेरी वेरी टाइम कंज्यूमिंग बिकॉज यू हैव टू शिफ्ट एवरीथिंग. If you want to delete any element, then also time consuming. सब right के ऊपर shift करना पड़ेगा, time consuming work, which is very easy in case of dynamic. Getting? So quickly we will discuss and where they get the memory, that you have to remember. Statics always get memory on stack, and dynamic take their space on heap. But याद रखना, heap is a managed memory. This is not managed, meaning प्रोग्रामर इसको मैनेज नहीं कर सकता. इसको ऑटोमेटिक मेमोरी भी कहते हैं. एंट्री पे मेमोरी मिल जाता है, एग्जिट डिस्ट्रॉय होगा. नॉट इन आवर कंट्रोल. यह कंप्लीटली आवर कंट्रोल, बट इट इज अननेम्ड मेमोरी. तो यह यू हैव टू मैनेज इट विद द हेल्प ऑफ पॉइंटर्स. Getting? So pointers is a very very important terminology. If you are not aware of it, please watch pointers videos in my C lecture sessions. Static best example is arrays. I have mentioned over here arrays. And in dynamic the best example is linked list. Okay. What is the basic advantage of this static? Direct access can be done. If you want to access any ayat element, it is very easy to access the ayat element because they all are in a contiguous storage and everyone is having fixed size, that is W. Getting? So if I want to come to ayat element, I just need the start address. See, everywhere mathematics is there. And just write I into W, that is the offset. One element takes W, so I elements will take I into W. That much offset you'll add to the start, and when you add to the start that much offset, you'll get the address of ith element. So to reach to ith element, it is very easy. Why? Because they all are contiguous. But in case of dynamic, that is best example is linked list. They are all scattered in the memory. Anywhere they can be, but still they are linear, remember. Meaning they are connected to each other. Here the address of this is kept, address is kept, address is kept. But if I want to reach to any ith element, you cannot directly reach it because they are not in a continuous memory. You have to come to first element, take the address, then visit here, then take this address, visit here, take this address, visit here. So that is the difficult thing. Direct access difficult. But here the insertion deletion is easy. If you want to insert it, just create another element wherever the memory is and just join the links. You just have to update the link. You don't have to do any shifting up and shifting down, which is to be done in arrays. Okay. So direct access to any element is fast as all the elements are stored at continuous memory location. That is, each element is at fixed distance apart from each other. As they are fixed distance apart from each other, we can directly reach to ith element. I already told how to reach to ith element. Take the start address plus I into W, where W is the size of one element. But that is difficult in case of dynamic. The example is linked list. Direct access to any element is not possible. Why? Because they are not in a continuous memory. But they are linear. They are linear, means they are connected to each other. First element is having address of next, next is having address of next. So if you want to reach to ith element, you have to traverse all the past I elements. See here. So direct access to any element is not possible. Therefore, slower access to element. That is the drawback of it. to access any nth element, we have to traverse all n minus 1 elements sequentially. Getting? Here the drawback is, here the advantage is direct access is fast. Here direct access is slower. Here the disadvantage is insertion deletion. If you want to insert or delete, as they're contiguous, you have to create a room. So you have to shift all the elements down by one location or bring it up by one location. Getting? See, expensive to insert or remove element because elements need to be shifted left or right one location. Getting? But here the insertion and deletion is fast. Why insertion deletion is fast? Because you just have to manipulate the links. Getting? Create a node wherever it gets a space, and the two nodes between which you want to insert it, you just have to manipulate the links. Getting? You will understand this more detail when we'll start with linkless data structure. Getting? Here the size is fixed, and that you have to announce at the time of compilation, which I already told. Getting? Here the size is flexible, means how much amount of memory to allocate is completely in our control, and that you can allocate at runtime, and you can give also back to the system if you don't need it. Getting? See, how much memory is to be allocated is decided at the time of compilation only, but here how much memory is to be allocated is decided during the execution. Programmers will. Getting? And static, they all take space on the stack. Dynamic, they take space on heap. If you are not aware about the memory organization of a program, how a program is divided into sections, that is stack section, heap section, data section, code section, so please watch the C lectures. There you will come to know it. Getting? And then coming to the fourth data structure, that is persistent and ephemeral data structure. Okay, quickly discussing about this persistent and ephemeral. When the values are preserved and you will be able to recall it whenever you want, it is persistent. And when the value is lost, getting? Your local variable, when you put new value in it, the old value is lost. That is ephemeral. A data structure that preserves its old version, and a data structure that doesn't preserve its old version. Getting? Previous version can be queried. Queried means you can recall. You can ask for the old value. Getting? In addition to the latest version. Okay, here you cannot query. Previous version cannot be referred further because the value is lost. In persistent only we have partial persistent and fully persistent. Partial means only the latest value you can recall, not the old. Getting? Like many times you remember whatever I teach you in the past few sessions. But if I ask you what I taught in the last year, what I taught you in LKG, that you won't remember. Getting? So that is partial persistent. And if you remember everything from your LKG session, means it is fully persistent. So partial persistent means allows update to the latest version only. And fully persistent means allows update to all the versions, previous and last and latest. Okay, so I hope you have understood all the four classifications of data structure and on what basis they are classified. Getting? So that's all for today's session. Hope you enjoyed learning these data structures type. Some more things in the next session. Clear? Thank you all of you. Keep watching, keep learning.